Let's see if we can get live. Crap, I forgot to bring water. I'm gonna run away in just a moment as soon as I know we're actually live and this is working. Okay. I'm not getting any audio.
Is it working?
Oh Jesus Christ, I am getting audio. Right, so before we get started, if the audio drops out, let me know, because this is a power bank in my left pocket, powering my microphone in my right pocket, because I forgot to disconnect the power bank that's taped onto my microphone, so we don't actually have any power in the battery for that, so yeah, just a heads up. I'm installing a very weird old camera surveillance system for somebody, and without going into too much detail, there's a switch mode power supply there that's just putting out way too much noise into the ground of everything, and it has to go. And I need it tomorrow, so we don't have time to order anything proper, we don't have time to do anything, so I'm just going to take these three 10 volt 1.2 amp wall warts and these two 7812s and this one heatsink and make a replacement adapter. So the original is specified for 12 volts at 3 amps, and yeah, that's what we're roughly going to create. These 7812s can do 1.5 amps each. These power supplies put about 14 volts unloaded, about 12 volts loaded reasonably. They work quite well with 7885s usually, so I think by just hooking these three power bricks in parallel, we're going to be able to do 3 amps stabilized at 12 volts, no prob. And we can solve the horrible noise issues in the actual installation. So strap yourselves in. This is going to be an ugly one. I don't think we're going to be bothering to make any kind of PCB for this. I'm just going to do it point to point, since we only need the 7812s and a couple of decoupling caps to do it all. Really low requirements for this, aside from the switching ground noise that we need to get rid of. So the point of this whole project is to make a power supply that doesn't put out any crap on the ground at all, because that's causing, like the microphones connected into the system this is going to, it's an in-wall wiring with the power cable, 12 volt power cable for this camera, and the microphones going in the same channels, and the power supply for the camera is just putting out way too much noise on the ground, and it's just going everywhere because it's powered by switch mode power supply in the equipment rack, and the camera is 50 meters away, as well as the microphones, and it has some weird, really bad microphone preamplifier that's got some really specific features, so we can't replace it. And yeah, it's just a big ugly mess. And just in this installation this is going to, I have tried messing around with it. Oh cock, where's my alcohol syringe? We don't have it at hand, we have to bring out the big bottle. I've tried mitigating the noise issue we get in the mics by just connecting ground every here and there, and it just does not do it well enough at all. We need a different power supply or severe filtering in each end, and I've made the judgment call that it's just easier to just dive right in, make a replacement power supply than trying to mess around with filters, because this is a quite surefire way of getting it working, and I think we can put this together in about an hour if I keep speed up, which I tend to do. Someone in chat says only needed tomorrow, not yesterday. Wow, things are improving. Yes, I'm good at planning. I always need things tomorrow. It's my customers that need them yesterday. Oh, people are complaining about the rewindy thing. Can we fix that? Okay, I think I just enabled the like rewindy thing. I think you should be able to rewind now as soon as that like gets applied, if it's in this stream or the next, I don't know. So let's start by just mounting these 7805 regulators to this board. We don't, since this is just going to be ground and I have like some plastic at hand, we don't need to insulate the regulator from the board, from the heatsink. It's going to be fine. I am going to need some tape though, so that we have some room to work on these. Someone's asking, when was the last time you got drunk? On stream? Quite a while ago. I don't usually drink on stream. It just happens occasionally. Which means like twice maybe at most. So for those who are just joining us, I'm doing a weird surveillance camera installation where we need to use a couple of microphones and a couple of cameras together, and they are all the wiring for both the cameras and the microphones are running in the same channels. That's not usually a problem. However, we have a really bad microphone preamp and a really bad power supply for one of the cameras. So what happens in the installation right now is we get horrible switch mode noise in the microphones, and that's just because the old switch mode power supply for the camera is just putting out noise, probably by design, and you can mitigate it somewhat by connecting the grounds together in all kinds of funny ways, but you can't get it good enough without just replacing the power supply and going linear. So that's what we're doing. I am looking for some thermal compound, which I am not seeing. I only have fancy PC thermal compound. Fine. I need to get myself some new normal cheapo compound. So what we're going to be doing today is taking 3 of these AC adapters, which are unregulated, transformer based, 10 volt DC adapters at 1.2 amps, putting 3 of them together, feeding that 10 volts DC unregulated, which is about 14 volts DC, into these two 7805s in parallel, and the output of these is going to be our new power supply, which is needs to be rated 12 volts, 3 amps. I don't need it tomorrow. I wish I could show you the entire installation. It's quite an interesting thing, but alas, I cannot, and I have lost a nut for my heatsink, and it's somewhere on the floor, and I have no idea where, so I think we're best off probably just getting another nut. Getting another nut from the box. So there's going to be a boardless design. We don't need a board. We have so few components. Just a couple of decoupling caps on the inputs and outputs of the 7805s, and we're going to be golden. There we go, beautiful. we can probably start by soldering the capacitors to the 7805s, and I'm going to need some caps. I can tell that I definitely need to get more 100 nano ceramics, but we should have just enough. 1, 2, 3 and 4, that's all we need. And I'm feeling lazy, so I'm just going to do this on the microscope. Point-to-point soldering onto loose TO220s is not difficult to do without magnification, but it is easier to do with. So, since we are in a bit of a rush for time, I'm going to do it that way. Someone says Arctic ceramic is a good cheap thermal compound. I thought that was relatively expensive, but I might have to check it out. Like, cheap in my eyes is one of those huge thermal compound tubes that you pay like 10 euros for at most. I'm talking like one of the giant ones, for example, that I use for my alcohol syringes. That's cheap. Jeez, I think this tip is really starting to die on me. I keep having to turn the temperature up. My side cutters are out in the van, so we have to use the big boy snips. But that's fine. That's fine. My usual tweezers are also out in the van. Oh well. Jeez, this camera is out of focus. A bit of flux on this. And on the caps go. So, since we have a fair bit of space, I'm going to install the caps facing the regulators. That gives us more space for wiring later on. Number 1. Come on, melt. Oh, come on. This tip has seen better days. There we go. That's a decoupled 7805. Someone's asking what my opinion on the, in quotes, D wave is. I don't know what the D wave is. So, do enlighten me, what is the D wave? And a bit extra flux on those guys as well. I have to turn the temp up on the iron slightly. This poor tip is dying so hard. It's just gasping for breath. Gasping. Okay, my entire soldering iron is dying. So yeah, maybe I should just replace the whole thing. Oh, come on. This poor soldering iron, it's beeping for mercy, beeping to be put out of its misery. That did not go well, but it's bad enough for us to just blob some more soldering onto it and it's going to be fine. There we go. That's soldered enough. Someone says the D-Wave is a quantum computer. I don't care. So that's the decoupling soldered onto the 7085s. That's all we need for microscope for right now. So the input on these is in ground out. Our grounds are going together right here. I'm still going to connect them. I'll just use a bit of wire, if my soldering iron would be so kind as to shut the hell up. So that's gonna go like meh. Kotchatorian in chat says, hello FF Cossack, pleasure to be here. Pleasure to meet you. Need some more water on the poor old soldering sponge. Bobby Blindy says, you could use a martini to settle those digits of yours. Why does everyone always want me to drink? Stupid plastic. Do you not need a microscope to solder a wire to the middle leg of a TO220? I do not think. God, this poor tip. I just have to get put on a different tip. This is not working out at all. Let's do the medium size one, the 1.6mm. This is a 0.8mm that we used to have. which I clearly need to retire. We can probably zoom that in a bit, just a bit. And this thing is smoking more than the other one. That's a good sign. Like the moment I put the other tip to the joint, it would just sigh and die. Yeah, this one's a bit better. So that's our grounds connected together between our two 7812s there. Someone says, those AC adapters always have a big value Chinesium smoothing cap after the rectifier. Yes, they do. This is a relatively low duty system, so this is actually not going to see all that many hours on it. It just needs to work when it's actually in use. Here we have, this is an output, like I'm using the case out of a some old broken Corsair power supply. Hey, that's not even that old, just broken. We have a little mains filter here, we might as well use that. So we'll snip this and just try and terminal block this onto all the inputs to the AC adapters. I'm going to need a rather big terminal block. This one ought to do it. So the point of this entire endeavour, to those of you who are just joining us, is to reduce noise on the ground of a surveillance system that's currently powered by a switch mode power supply. Now that switch mode power supply is giving everyone's ears a very bad time because it's coupling into the shield of a microphone cable, and that shield I think is used for powering the microphone. So even though it's a balanced signal to them, like on the audio side of the microphone, there's still like utility in the shields. That's not just shielding. It's not a very good system. So we'll cut like a reasonable length of wire. Let's have a bit too much and a bit too little. So these guys are going to go here. The only reason I'm using 3 small power supplies is because I don't have one big power supply. Or maybe we need to figure out. I'm quite sure these are going to fit inside of this case, all 3 of them, but we need to Tetris them together properly. Is that going to work? Well, that could actually work if we get rid of this plasticky thing, which we don't need. Let's give this a go. I don't think that's actually going to go. Or maybe. Well, that works in theory, as long as we have enough clearance for our wiring, which I think we might not. No, that's not going to work at all. And perhaps I had these in here at one point in a way which worked, but I've clearly lost the art since then. I think it was like that, and then this guy went like that. Yeah, that works. That works. If we made them like that, we can easily fit everything together, and the regulator PCB can go on there with a bit of plastic to shield it from the metal case of the phase supply. So, yeah, this is going to be alright. This thing should actually turn out to be reasonably efficient, since the voltage drop across the regulators is going to be quite small. These are 10 volt unregulated power supplies, so they put out about 14 volts DC at idle. So that's a reasonable amount of one. So the voltage drop across these 7812s is basically going to be the minimum allowable voltage for them to stay within regulation at all. It's going to be like 2 volts max. So these are our AC inputs, and that's just going to go like this ish. And we should install a DC output. We can use one of our mains cords for that. Someone's asking if I still work with a radio transmitter. Sometimes, not usually, but sometimes when necessary. I'm not allowed to bring cameras there anymore though. Snap. Oh god, I just filled this entire box up with copper strands. Yeah. That went completely wrong. Someone asked where I lived, and the chat very kindly replied in my place. Thank you. I didn't notice. Thankfully this thing is going to be very firmly installed in a rack, so it does not need to be superbly mechanically sound. It just has to be electrically sound, because I can mount it in a place that doesn't allow it to move. I need a blade. There is a blade. These blades are very useful tools. I recommend everyone to just buy a bunch of disposable like box cutter blades and use them hands-free. They are a lot better than most knives at doing precision work, like splitting open a wire like that. Because if you get a bit good, you can get quite good precision of these. Bobby Blind is SC from New Zealand. That's far away. I didn't realise people were up there at this hour. I suppose it's really early, middle of the night in New Zealand right now-ish. I don't know. I'm really bad at time. For a long time I actually used complete box cutters, but then I just took the blades out and noticed that using the blades themselves was much better than using the actual box cutters. Station 240 says it's 1:30 AM here in Australia. I see. That's weird. Station 240, for some reason I thought you were Swedish. Probably because you have 240 in your name and every Swedish boy racer drives a Volvo 240. I am genuinely surprised to hear that you are not Swedish. For what it's worth, at least we're going to have triple redundant power supplies for this camera. 3 really bad power supplies in RAID 1, is it? I never have my RAID levels proper. The mirrored one. I think it's RAID 0. In parallel. So this is actually going to fit together quite well, I think. It's going to be absolutely beautiful. With 230 volts and 12 volts and everything in between all over the place. Right, let's think about our output wire and how we're going to rate that, because that's going to be an issue. I think I'm just going to zip tie this to the grill so that it has some kind of strain relief, and we'll take it out through the ATX power hold. Someone says it's 9:10 AM in Orange County, I'm guessing USA. Good morning, USA. So this is an 8-bit lead. I will be smart to cut this plug off this lead before we install it. Else I'm just going to end up plugging it in on the secondary side and completely destroy it. We were going to zip tie the power supply lead in place. That's what we were doing. Just tie a knot around it, so like so, zip tie through the knot, and we're going to be golden. Kachaturian asks, is the court in Louis Rossman's video the same as all Scandinavian courts? I don't know. I thankfully haven't had to deal with the court system. But generally, that kind of stuff is reasonably serious around here. Like, it's much more serious than it's usually viewed in America, for instance. There we go. I put wire securely in place. And these power supplies are like, the power supplies are not going to actually be mounted down. They're just going to be loose in here because it's going to be so tight once everything's together. They're just going to kind of rub up against each other, and it's going to be fine. So output lead goes meh. Yes. We could probably do with like, oh yeah, we need to actually hook all the pins and these up in parallel, since both of these regulators are going to be completely in parallel, so let's just do that. Oh man, this camera's aimed in all the wrong places. Air, wire. So that's gonna be like mere length. Someone said I should epoxy this in. No, Jesus Christ, no. Epoxy is the devil's glue. Hate epoxy. Just smells bad. Just smells bad, man. Now that's an 8-bit. 1, and that's going to be 8-bit 2. We will make a mild effort not to short circuit everything. And one final wire. This thing will be impossible to diffuse once it's done, because every wire will be green. It's the ultimate tool of terrorism. More flux. Rossmann demands more flux. We must appease the Rossmann gods. Oh god, that's so incredibly bad. That's going to be fine. And we are resoldering the other end of that, because it turned out really, really, really bad. There we go. There we go, that's two 7812s in parallel. So now we can start thinking about how to actually wire this up. I think we'll probably be smart to not solder all the power supplies right into this. Or maybe we can. Yeah, I think we actually should take a couple of leads from these and put those into a terminal block going to the actual power supplies. Make it a bit more modular. Terminal block. I'm going to take some nice colourful wire. Always keep an extra ATX power lead. So this is our input, and we're going to need 2 grounds because one's going to be for the input and one's going to be for the output, as well as one output, which will make ATX yellow. We are compliant. I mean, this is an ATX power supply after all. I think it's quickest to just strip these using the blade. Yeah. Blade is love, blade is life. I should probably get some more proper stripper at some point. I mean, everyone else has a proper stripper. But you do get very good results with a blade. Oh, forgot that one. Spin. There we go. Someone says I should add an LED. An LED would actually be a good idea on this, so we have some kind of power indication. I may add one. Yeah, let's just get to soldering a shit ton of this stuff. We can probably do that under a microscope, just to minimize the risk of accidental bridges. A stupid thing. So we'll make a red input and black ground, of course, and yellow output, and these are in ground out. Now you get to see my horrifying solder jobs up close and personal. Also have to tin the wires first, I guess, because else we can't reflay them in place, but that's just going to take a second. I do not want to be doing this tonight. I was hoping to be done with this installation, like yesterday. But alas, sometimes things don't go to plan. flux. Oh, why did I pin all the pins? We're not going to be using all the pins. Oh god, I have shorted the 8-bit there. I have shorted the 8-bit. We do not need our 8-bit to be shorted. This is not a MacBook. This is a quality device. No longer shorted. That's just flux. Yes. Ground. I need some extra solder for this one. Input. Fume extractor. And output. Need more solder. Need more solder. Need more flux. Need to reflow that because it's cracked. These joints are not mechanically sound, by the way. This needs to be installed in a stationary application, or it is going to fail on you if you do the same thing. This is like a bad way of doing things. Do not do things this way. Okay. That's really horrifying since I messed with it. There we go. Oh yeah, we need another 8-bit. And since these grounds are tied together so tight, we can just shove it on the other regulator. That's going to be fine. These are tied together through the heatsink as well, so we're not just running all the current through a little tiny green wire. There we go. There we go. There's our circuit. Input red, ground, and output yellow, and the other regulator just in parallel, and this is like our output ground or something. It's amazing quality. Good PCB. Wait, we don't have a PCB. Good thing. Point-to-point piece of crap. So I want our output. We're gonna need another set of screw terminals. No, why am I not just soldering the 8-bit lead straight to this? I'm stupid. I'm gonna desolder the 8-bit leads actually, because we'll just solder the 8-bit leads straight onto the regulators. That is way too big a screwdriver. God, I have so much of my gear out in the van right now. Someone says something about wrapping strands around the legs to make these solder joints better. Yes, I usually do that. Like, this is a bad thing. This thing is not going to be durable at all, not mechanically. But it doesn't need to be. So yeah, we're just going to get rid of these, because we'll solder the 8-bit wires directly onto the regulator. So no ATX yellow compliant wire. And 8-bit is what's our output? That's our output. So we'll do that one last because it's going to be very firmly attached. Now I think we might actually be able to like bolt this to the heatsink. Yeah, that'll mount beautifully. If we can just find like a long screw to pull through it, that'll mount beautifully. We have quite a screw and a nut. I think this is going to be fine. That's going to make this slightly more durable at least. This is going to be way too long. We need one that's like half the length of that screw. And we can just put the screw in from that side, since it seems to thread onto the terminal block quite nicely, and just literally screw it down. Amazing. There we go. And now all our 8-bit leads can go into that terminal block. I think the white one is positive. The white one is usually positive. Let's just diode test that to make sure. So I think this is going to give us a diode drop. Yeah. So that's giving like 1 volt, and this should read open circuit. In due time. Open circuit. Yes, so the white striped lead is our positive. The lead without the white stripe is our negative. So I'll just shove all of these in there. Black, 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 we are segregating so hard right now. we need to be somewhat careful though, since this heatsink is actually a negative for everything, since it's connected to a tab of our regulators. Come on, in you go. And of course one of the positives thread all over, and we can't have that. Come on. Yeah. There we go. Forceful entry. Okay, so that's our input to our regulator board setup. It's beautiful, magnificent, amazing. Now we can probably be well served by installing our mains leads, and in the end we will install the 8-bit lead, since that's soldered directly. We want to do that last. Oh, I was just about to poke our 8-bit lead into the mains terminal block, since it's an identical cord. We don't want to do that, that's a bad thing. Come on, get in there. There we go. And all the blue ones as well. Tighten that down. There's nothing looking horrifying. Okay, now the final step is soldering our 8-bit lead to the regulators. And then basically putting a plastic piece over here, and then this thing is done. And it's going to put out 12 volts and nothing's going to be broken. This will work first try. This will work first try. There will be no smoke, no fire, no nothing. There will be no problems, no recalls, no remorse, no regrets. No, nothing. Nothing bad. Nothing bad. There will be nothing bad. And this thing will run for 100 years. So this is our grind. 8-bit grind. And 12 volt 8 bits. and the 12 volt output would be well served to be on the other regulator, since now we're pulling all our 12 volt current through this tiny wire, which we could probably do with like making just a slight bit fatter. 3 amps shouldn't be an issue for this wire, but let's just make it a bit fatter. It's easy enough to do. This is going to be the part where everything goes wrong. The tiny little final modification to make it a little better is going to be where the power supplies fall apart, the smoke comes out, everything just destroys itself. But it didn't. So that's an extra little tiny green lead. To carry all our 12 volt current. Okay, so this should actually now work. This should be a completed product. So let's strip the output wire, then apply 230 volts, because since these are transformer power supplies, there's nothing else we can apply. Someone's talking about showing dirty pictures to wires. I don't know what kind of wires you have around the house, you dirty-minded prick. And let's just bring in a meter. With some proberos, and if these probes are not broken and my design is not flawed, we should be seeing 12 volts on this meter when we plug in our IC. If we see anything other than 12 volts exactly, something has gone very bad. But I don't think anything's gonna go bad. This will work first try. This is gonna work first try. So here comes our power. It's not straight out shorted now. Our output lead is going to the regulators, or the, yeah, nothing should go on fire. Okay, here we go. Oh yeah, take 2, I forgot to turn off power. Hey, there we go. He's drawing 10 watts in standby. But that's a quite clean 12 volts, which should be nice and current limited and good to go. So let's try and lower that down a bit. I have 4 ohms coming in. This, let's just 12 divided by 4, is that like 4 amps? So that should put into current limiting. Let's just verify. 12 volts, resistance 4. Oh, that's 3 amps, so that should be just about the limit of what this can do. So having a little bit of drop when we hook these on is to be expected. Let's Let's give it a go. I'll have to put some like clamps on this, I think. And we can just use another couple of probes. Bobby Blindy, I'm not quite sure what you're trying to say, I'm sorry. But it sounds inspiring. Okay, so 9 volts, yeah, to be expected since we're just like have a maximum. Let's see if we give that 8 ohms, that should be fine. It's not fine. So on 8 ohms we have 1.5 amps. So that's actually pulling the voltage of the power supply down too low. Well, that's a bit of an issue. It shouldn't be drawing that much power though. Well, this is bad. I don't like this. This is not what we intended to do. This is not an 11 volt power supply, this is a 12 volt power supply. But it might just have to do. I think if we prove the input voltage we're going to be too low. Yeah, 12.8 into the 7812, so there's no way for them to maintain that lower voltage, dropout voltage. But I think this might actually work. The camera is not going to be drawing more than an amp or so max on normal operation. So I'm just gonna put this together and hope that it's going to be fine. If it's not fine, I'll just have to basically order a more proper power supply for it. But for something we can put together in a night, this is going to have to do. Now that's a shame. I was hoping this would work a bit better, but oh well. So we can just like squeeze all this stuff in here, hopefully. That will work, by just kind of squeezing in there. If we take a single zip tie around there, that's going to stay in place. So for this to work properly we would need power supplies that are capable of a slightly higher loaded output voltage. I'll just shovel this stuff in there. I will take the plastic power supply holdy thingy. If we put it like that, it'll be fine. It's going to be so tight, it's just going to squeeze everything in place. That goes on which way? Doesn't matter which way is the Corsair logo on. It kind of seems it doesn't matter. This thing seems quite symmetrical. And we will use a lot of brute force to get this on there. Frosted good. Ta-da! Ta-fucking-da! Ha! That's not so bad. So, as long as this manages to provide enough current, we're going to be good. I'm skeptical, but this is what I can do for the time being. I have a screws for this thing somewhere around here. Someone asks, now for a real test, does it still have the countersunk screws for the ATX case? Oh yes I do. Oh yes I do. You thought I wouldn't have them, eh? You thought I wouldn't have my screws, eh? You think I don't know a thing or two about screwing? I know all about screwing. And I never let a good screw pass me by. If only these power supplies would have put out like 1 volt more. 1 more volt and we would have been golden. I was hoping by using 3 we would arrive at a good enough performance figure, but seems not. But hopefully there's not going to be enough 50 Hz ripple coming out of this to cause issues. I know the camera is somewhat immune to that, and the 50 Hz ripple on the power line is not actually a problem. Now for the obligatory rattle test. No, that's not even. Come on. Stupid wire is getting my hand. Free access rattle test passed. That's not too bad. That's not too bad. So let's see if it still works after I put the case on. And let's see what the actual maximum current output is. Hey, the power switch should even work. Let's get a test light of some kind and see if that's actually the case. Do we have something that can hook up to that thing easily? We have a small fan, and we can use a couple of our proby things to just clamp that on. There we go. So we will now, for the grand premiere, turn the power on. The power is on, and as you can see, the fan is not turning. That is because we have a power switch. So if we apply pressure to a power switch, like magic. Although we can quite clearly have a fan, but if we load the thing down a bit, this is going to be bad. We cannot get a lot of current out of this thing, sadly. Sadly. I'm probably going to shove a capacitor in the terminal block this goes into, just to make it a bit less ripply, and then it's going to be fine. But yeah, that's as much linear power supply as you get in 1 hour and 16 minutes. And I'm going to spend a second on this thing that I don't need to. So we are done. I'm going to read the chat in for about 1.5 minutes now, and then we're done. I don't want to be working anymore. I've been working bloody well 10 hours today already. So what's the chat got to say? Shrink tube on the transistor joints, perhaps? Nah, who needs that? This is fine. Perhaps a mirror ball strobe light. Yes. Oh yeah, I forgot the power LED, but I don't care. Long screws, good for heatsinks and screw terminals, bad for MacBooks. The chat says. Are you human or android or cyborg or AI? Would an AI produce this? The answer is no. This is the ultimate Turing test. An AI would never, ever create such an abomination. Bobby Blindy says, the South Pole has just stopped moving. Quote, the drain of ultimate PC FF power PC Silla. I have no idea, man. What are you smoking, Bobby? What's he smoking? Raven Rampkin asks, just wondering, missed the start of the stream, how would you rate the casing tone of a VS550? This is the only one I've ever seen, and it's broken, so yeah. Bulk quality was not very good, shitty caps in it, etc. This one had some weird issues, I just scrapped it, wasn't worth fixing. So I don't really have an opinion, this one was bad or no. But yeah, we're done. Thank you all for watching, have a good night.